Hi, Professor. This is Vishwanath Verma, and I'm here to give my presentation on the risk assessment of additional works in railway construction investments using the Bayes network. So, coming to the abstract, the application of the railway infrastructure projects with long-term development goals is a complicated task that is necessary for a substantial extension of individual investment stages. So the requirement for additional work has a massive effect on the railway building projects, posing a risk due to a variety of factors. During the execution of works, both the design presumptions and the circumstances of the implemented project can be changed. The attempt to remove potential risks is a critical component of a construction project. So in this paper, the authors propose a patented technology risk management technique for increased work risk in railway project. So a technique for creating risk management strategies determined by the standard algorithm, including risk identification, risk analysis, and risk assessment is presented. So the work's distinguishing features include identified risks, followed by analysis with Bayes networks. So it is demonstrated using a event scenario as an example, how a well-programmed network can be used to enforce risk mitigation methods. So using the network, one can compare the various risk education methods, analyze and influence of risk education measures, and decide a decent standard of effects, such as great financial resources in the context of additional work. So coming to the introduction, the application of large infrastructure development projects is accordance with the sustainable development goals in a multi-stage process. So most significant investments can take several years to complete from the creation of the initial concept to the commencement of the project. And the situations related to unknowns occurring during the project implementation are referred to as risk, while the activities taken to maximize the impact of the risks are known as the mitigation risks. So, as per the paper, in Poland, a large EU project is currently being implemented with the goals of modernizing the country's railway network. So, as a part of the planned investments, 9,000 kilometers of railway lines will be built and modernized. So, implementing such an ambitious plan entails numerous risks, including the possibility of unforeseen or additional work. So choosing the right risk management strategy will mitigate the negative effects of risks while ensuring that investments and objectives are met. So the effect of new issue are manifested as a transformation in the duration of the investment capital or a change in the project's cost. So the impact of events, like the likelihood of occurrence of risk, is determined by the specifies of the implemented undertaking or legal conditions. So there has been a lot of research done on the various stages of risk management. So coming to the, so as we continue the introduction, the bigger investments can take several years to achieve, from the creation of the original prototype to the commissioning of the object. So risk refers to the unpredictability that arises during implementation of the project, whereas risk mitigation relates to action taken to mitigate the impact of risk. So a well-chosen risk management strategy that takes into account through scenarios for dealing with a variety of risks can assist in ensuring that a planned work investment is completed on time within the project. So the ISO standard defines risks as a combination of uh, the event's consequence and the likelihood of its occurrence. So in the light of foregoing, risk is defined by the function of R equal to F of P comma C, where R denotes risk, P denotes the possibility of a specific event occurring, and C denotes the event's impact or consequence on the final effect of the implemented project. So risk management and its guidelines. So the main component of the method will be the Bayes network model, which will be used to build from expert interviews. So research in this field may include studies on the factors that cause additional work, as well as discussions about awarding contracts for individual work in the road investments. So this is a cycle of the risk management strategy as per the authors. So it includes estab- establishing the content, risk identification, risk analysis, risk evaluation, and the risk treatment. So the subject of additional construction works is rarely addressed in the literature. So until now, there have been few works that discuss the commonly understood changes that occur during a construction project. So some researchers describe factors that influence the occurrence of additional works, whereas others have conducted studies to assess the effects of additional works or changes. So when analyzing additional works, it is critical to consider the local conditions in which the construction project is being carried out. So studies on these factors that cause additional work, as well as discussions about awarding contracts for additional work in road investments may be included in the field of research. So the consequence of emerging risk manifest as a change in the duration of the investment or a change in the project's cost. So the specifies of the implemented undertaking or legal conditions determine the significance of events as well as likelihood of risk occurrence. So there has been a great deal of research done on the various stages of risk management. So the best mathematical models are also carefully selected, and multi-criteria methods, Bayesian networks, and fuzzy set approaches, among others, are used for risk assessment, resulting in the group of models. So framework model for risk assessment method. So coming to this, comprehensive identification of all variables can be difficult. However, the registration process should be carried out as thoroughly as possible, taking into account all contexts, factors, and conditions specific to the discussed issue according to the adopted methodology. So risk assessment techniques, which define the most widely used techniques for hazard identification and analysis, can aid in the risk identification process. So we have three steps here. So identify risks, analyze them, and evaluate them. So each stage refers to a different procedure in the risk assessment. So the provisions of the standard discussion on the main assumptions and actions that decision makers managing risks in the enterprise should take for each of them. So the standards main method mentions 31 methods which are classified according to their usefulness in relation to the problem and assigned a level of suitability. The appropriate technique is chosen based on the characteristics of the risk under consideration as well as unique circumstances. So stages of the risk assessment. So the obtained results will be further analyzed using the Bayes network, which allows modeling with high uncertainty or on the basis of cause and effect inference. So risk assessment will be carried out using the consequence or probability matrix, which according to the authors allows us to clearly determine the risk level of risk and carry out risk mitigation activities. So the above methods, which are chosen based on the current state of knowledge regarding additional works in railway investments, are to obtain input data on the issue. Expert knowledge was gathered through structured or semi-structured interviews. So the obtained results will be further analyzed using Bayes networks, which allows modeling with high uncertainty or on the basis of cause and effect inference. So identification of risk of additional works in the railway projects. So it contains of actually 4 steps. So uh, first, specify factors initializing the creation of additional works in railway infrastructure construction and investments, and moreover indicate the probability of their occurrence, and specify the type of construction works that occur with the occurrence of additional works in railway infrastructure construction investments, and indicate the probability of their occurrence. And third, specify 3 time periods which are most likely date for extending the duration of the railway infrastructure project as the result of additional works, and specify the probability of their occurrence. And the fourth is specify 3 amount ranges which are most likely to increase the financial resources that the investor must obtain for the implementation of the railway infrastructure construction project as a result of the additional works, and give its probability. So the experts were carefully chosen and the research is done through interviews. So the authors purposefully chose each respondent to represent a different company. So next comes the risk identification for additional works and results. So here, as we can see, there are risk factors for additional works, for additional types of works occurring, time period, and the amount. So this is a chart of the risk analysis that the authors had gathered from different authors. So risk analysis using Bayes statistics and the Bayes network method. So the Bayes network methodology was adopted for risk modeling because it appears to be the best fit for the problem, since it is based on the probability of events and allows for the introduction of new information into the model using technical expertise or historical data. The risk assessment was broken down into 4 steps, including one that was linked to the Bayesian network infrastructure. So coming to the selection of factors used to create the model. So those include the bad organization of works, change in design solutions, the errors and incompleteness of the documentation part, track and drainage works, network works, engineering objects, roadworks and railway crossings, and extension of the investment duration as the result of additional work. So for instance, there is Nitika software, which was used to build the model in the form of a Bayes network. Result analysis was carried out in 4 stages that were related to the Bayesian network design. So the steps include creating the nodes for the Bayes network, giving relations to particular nodes, and assigning event probability, and then comes the investment duration plan. So creation of nodes on the Bayes network. So the Bayes network nodes were created based on the variables and the possibility of additional works and the consequences of this phenomenon. So the risk assessment model has 9 nodes. Each of them was given a set of unique events that corresponded to the characteristics of specific nodes. The correct structure of the Bayes network is built on determining the relationships between individual nodes in the network. So far, various methodologies have been used, and they are dependent on the number of factors, including but not limited to the characteristics of the phenomenon and the investigation, data availability, and the problem's complexity. So next is assigning event probabilities. So each event must be assigned a probability of occurrence for the model to function properly. Furthermore, the Bayes network differs in that the events of the first node are introduced directly by defining the probability level. So to represent other nodes connected by reciprocal interactions, The so-called conditional probabilities, which are based on the chain technique, should be used. So this requires the writers analyzing and calculating the probabilities of all possible consequences or events. So table 7 represents the conditional probabilities of the additional notebook. And next comes the performing the calculations. So the essential relationship used in the development of the Bayes network is the Thomas Bayes theorem, which binds the conditional probability of two occurrences conducting each other. So by applying this theorem to a series of events, we can calculate the probabilities of all occurrences in a network. So creating large network necessitates the use of appropriate programming, which can be difficult. So P of A by B equal to P of B by A into P of A by the total probability is the Bayes theorem. And A into B by whole probability gives the conditional theorem. So once the model was ready, calculations were carried out. So the conditional probability was calculated using the Nitika software. The computation results in a functional network that can be used in the next stage of risk assessment evaluation. So risk evaluation, building a risk evaluation matrix. So before the risk assessment can be started, the subject's risk criteria must be established. So the authors have discovered an approach to the work in the accessible literature on the risk assessment. So they divided the matrix methods to risk criteria. So the estimated values of occurrences and effects are shown in table 2 and table 3, where table 2 gives the event probability ranges and table 3 gives the event effect ranges. So when using a matrix to assess risk, you must define ranges of probability values and event consequences, as well as assign point values to each range. For event probability, 5 interval matching the assumed probability levels were proposed, while 3 intervals related to incidences that result in a long implementation period were proposed for event effect. So building a matrix. So to match the risk of the appropriate level, a point range of 2 to 50 has been established. So the table 4 shows the risk level ranges as well as the point values and action options. So when comparing risk criteria, a reference to expected risk levels is required. For the purpose of analysis, 4 levels of risk, low, medium, high, and very high, were provided, as well as possible event scenarios. So the scenarios include a suggestion for better risk management. So the next comes is the risk evaluation matrix with point values. So the matrix should be filled with both the assumed specific risk and also the risk consequences in order to evaluate the risk. So each matrix cells, point values and color were being used to describe it. The hue was selected based on the risk level as follows. So low level is represented in blue, medium in green, high in yellow, and very high in red. So the risk assessment matrix is as shown in table 9. So next comes is the events in scenario analysis. So the scenario investigated will be the occurrence of a risk factor such as project documentation issues. So this occurrence is depicted at the top of the diagram titled project documentation errors, and to investigate the scenario in the faulty event, 100% probability was required. So figure 10 depicts the consequences of an event involving insufficient design document. So this includes all the bad organization work, the results of and the probability of each of roadworks, networks, track works, extension of time, and all. So the proposal plan. So the optimal risk management plan is determined by a number of criteria and includes a response to each type of risks in the project. The action plan is chosen to maximize the effectiveness of the actions carried out. So the following are the most commonly used strategies: risk evasion or transfer of risk reduction, risk acceptance, and plan for the emergencies. And coming to the conclusion, the authors described one method for creating risk management plans that is based on a standard methodology that includes risk identification, risk analysis, and risk evaluation. So the chosen case employs a one of a kind technique based on the Bayes network. So using surveys, historical data, or expert opinions, this method can be used to model complex effect networks. So as shown in the event scenarios earlier, a well-programmed network can be used to deploy risk mitigation measures and evaluate their impact on other network nodes. So mitigates are preventative measures that reduce the likelihood of risk factor occurring. So thank you, and that's all about my presentation for today.